Hey, Thomas.
Hey Hugo, hey everyone.
Great to see you as always, man. How are you?
Very good. How are you doing?
I'm well. I'm well, and very much appreciate you joining at a late hour, knowing that you're in Germany currently. Is that right?
That's right. Yes.
Cool.
Beginning
Um,
of Frankfurt.
Fantastic. So, welcome everyone. I'm very excited about this session. As I've messaged in Discord, the Q&A will happen in the channel Special Guests November 2025. And so just post any questions for or any thoughts, reflections for Thomas there. I'd just like to say a few words by way of introduction for Thomas. Thomas is CEO and co-founder of PyMC Labs, co-creator of PyMC, and does a lot of work. We met through Bayesian inference circles, but the real generative modeling, as I like to joke. And finally, Thomas, we had Ravin come and talk about products he builds at DeepMind earlier this week. So it really is a Bayesian week in many ways. But Thomas has a really interesting background from all the PhD research he did on, among other things, computational psychiatry at Brown, then VP of data science and head of research at Quantopian, then moving into all this wonderful Bayesian stuff. On top of that, Thomas has just been really inspiring in the work he's been doing in the generative AI space. So, and we've spoken about this before on a podcast, among other places, but we're doing really interesting work on generating synthetic data to help organizations make business decisions. And in particular, Thomas will be talking today about generating synthetic consumer survey data, work he did with Colgate with respect to toothpaste, among other things. So I'm wondering, have I left anything integral out there or made any egregious errors, Thomas?
No, I think that's a great intro. Thank you.
Fantastic. Well,
So,
let's jump in.
yeah. Well, thanks, Hugo. Thanks everyone for tuning in. This is going to be about a paper that we recently put on archive that went somewhat viral. And I also think it's just a really neat solution to a problem that people have been working on for a long time. So, well, long time, I mean, since Gen AI, right? But we have synthetic consumers and this idea that we can recreate survey responses from LLMs has been around at least 2 or 3 years. So synthetic consumers, obviously the appeal is there, but how do you get them to work? And like Hugo said, this is work we did with Colgate together. So he already alluded to this, but the company PyMC Labs is a Bayesian AI research company. So originally we come from Bayesian modeling, and now we bridge that to generative AI. There's a lot of cool synergies between them. This one is more like solidly in the Gen AI space. And so what is the problem that we're trying to solve? We have product concepts, right? And they actually don't even need to be product concepts, but this is the starting point. Later on, I will also say, or can you just like use ads, right? Or anything really you want to evaluate. Here we're starting with a product idea for a shampoo, and it has artwork, it has text, and then we ask, how likely would you be to purchase the product? And we do surveys people have been running for a really long time. So we have Likert ratings. You get n number of participants. They say like 5, definitely gonna buy it. 1 would never buy it. And then you do histogram, and that gives you your survey response distribution. And in this case, a lot of people say 5, so this seems to be a good product, right? A lot of people tell you in a survey that they want to do that. So the data set that we started out with is from the personal care on the US market. Overall, there were 57 products, and for each product, a survey, each one of 150 to 400 participants. And we collected also demographic information. And the models we did were GPT-4o and Gemini 2 Flash. We tried a whole bunch of other LLMs too. At the time of when the research was done, these were the frontier models. So that's why there's not GPT-5 here yet. But of those at that caliber, those were the ones where we got the best results. Other models didn't work as well. And we asked for purchase intent at the LLMs. And so wouldn't it be nice if we can find a setup where the synthetic consumers consistently reproduce real behavior? Now, when I say real behavior, what does that mean? How do we measure success, that we're actually doing something right? We looked at two different type of statistics. We want to estimate the overall distribution. So in black, again, we have the purchase intent histogram. And then in orange, we have the reproduction. So here's a good reproduction, right? The AI gives similar responses to this, and we can measure this with the KS distance. It's a similarity metric basically between two distributions. And then the other thing we want to look at is just the reproduction of the average purchase intent per item, right? So every dot here is a single product. And then we have the actual surveys that we send out, the mean purchase intent for that particular product. And then here we have the synthetic reproduction, which is what comes from our models. And there we're going to measure R. And there's one other metric, I'm just going to go over it quickly, but basically, because these are noisy measurements, we can estimate the noise in the distribution and say what is, because we're not going to do better than like if we were to reproduce the same experiment. So we have an upper ceiling of what the correlation, the maximum correlation is that we were hoping to achieve. So the main metric that we're reporting is what percentage of that noise ceiling can we reproduce? I think intuitively it will make sense. So for every survey, we compute cohort response means and then correlate that, repeat that 1,000 times. So how would you solve that problem, right? Most people so far in the literature, they just ask the LLM, they present the stimulus, and they say, give a response rating 1 to 5. And you only allow one of them, and then the model says 4, you record that, and then you look at the correlation or success metric, and you find that it does not work really all that well. We get pretty low correlation coefficient, and the reproduction factor of 82% is also not that great. Now, it gets even worse if we're looking at the overall response distribution, right? So here, basically, you see that for each different survey, so this is just a selection of them, we have the distribution and we have the synthetic distribution, and you see that it's basically always saying 3, right? No matter which product, it's always like, I don't know, it's kind of cool. So it's really hedging its bets. And this is something that you often see when you constrain the output space to this somewhat artificial thing. It will just try and avoid conflict, I guess, and say something middle of the road. So this is what we're seeing here very clearly. And obviously, this means that the results are pretty useless that we're getting here, right? If it's only saying 3.
And Thomas, I will need to fact check myself, but I think when people did research into using LLMs as random number generators, I mean, not using NumPy in an LLM to generate code or something like that, we did see that 7, between 1 and 10, 7 was far more overrepresented, and 3 was between 1 and 5 as well. And that may come down to training data as well, right? So,
yeah, exactly. So all these biases working against us here. And we saw that that is not sufficient, right? So for what we were trying to do and what the client was looking for, that will not do. And we took a good, hard, long look at this problem and really thought about it. So basically, this is a mess. But what we came up with, more specifically, Ben Meyer, who's the first author of that paper, he came up with this, and I think it's really smart. It's simple but effective. The best solutions usually are. So the answer is simple. Instead of saying just give responses 1, 2, 3, 4, 5, you actually allow it to give a brief textual response. So for example, the LLM might say, oh, I'm somewhat interested. If it works well and it isn't too expensive, I might give it a try. So then that is much more natural, right, for the LLM. It has somewhat of like a thinking space where it just like can write things out. So that makes it levels the playing field maybe. And now the question, of course, becomes how do we map that back to quantitative scale, the likelihood response, right? We do want to compare it, so we need some method to match it back. And that's really the finding innovation. So what we're doing is we're taking the answer and we are mapping that into an embedding space. And so that's now a vector, thought vector, like people have called them. And now we also do embeddings for reference responses that we say correspond to not likely at all to buy, and we do an embedding of that, then somewhat unlikely to buy it, next embedding, right? And so on and so forth. So we have these reference responses that link to like at rating. We get a vector, and then we can compare the vectors, right? So if we now want to say, how is the synthetic response? What does it most look like? Then we can just compute the cosine similarity, right? The angle in a vector space. So we do that for every pairwise vector to the reference vector, and then we get a distribution. And that is going to be our response likelihood. Does that make sense so far, that method?
It definitely makes sense to me, and people haven't asked clarifying questions around this, so I think it does.
Can you still
So
measure the error, Thomas, on this?
the error, I mean, there will be inherent error. Yes, yes, we can. So yes, so does it work, right? That, I guess, is the key question. And I personally was really amazed by how well it worked. I still can't quite believe it, but this is what it looks like. So for both models, right, and they're totally different models, we get pretty strong correlation between them. So basically, this is 90% of what is the maximum achievable. So that's not nothing. And then if we look at the similarity ratings, also we see that now the model is not just responding with a single three all the time, right? But we actually get also like an eerie similar reproduction of most of these distributions. And each time I'm telling it, I'm like, how does it work? Because there's no training here, right? So we haven't fine-tuned, we haven't given the survey responses or anything. We're just asking just vanilla LLM, here is the product thing, what do you think? And then it says, and then it reproduces these effects. So something in the pre-training, right, must make it think like humans do, right? That's what they're trained to do. And in that is the ability to answer to novel product ideas. Who would have thought? This stuff is wild. There's even some benefits here. So over human surveys, one fun thing we found is that if you just ask humans, right, they're pretty lazy. Certainly I am. And they would just like say, oh, it's good. Just some half-assed sentences. And then if you ask, however, the LLM, you get like really proper answers. So they're like better students, I guess, than the humans are, even though the humans get paid to do the surveys. I might consider purchasing it. The ease of use and safety are appealing. And so this is really cool because if you're developing a product, well, now you get really useful feedback from the LLM that, of course, you can also summarize. So then another thing that is really frequently observed in surveys is, even though they're pretty lazy with the responses they're giving, they actually are more likely to like a product than they then are in reality to purchase it. So humans, if you pay them money or you have lab coat, you want to appease to them, so you rank things higher. So this bias is really well described in the literature. And so obviously humans have it and it messes up results, but the LMs actually don't have it. So they're more neutral, I guess, less biased by the data. These are some responses from the LLM. So the wildest thing, though, for me is the demography data. And so this is, before I could have maybe brushed this off a little bit and be like, okay, well, I don't know. The results do look strong, but who knows what's going on. But what made me believe that this is something real is how well we reproduce the demographic data. Well, actually, here is a better one. So here we see that in real surveys, right, we have effects of income. So if you have very low income, you are less likely to purchase toothpaste on average, right, or whatever brand. And then with more money, you potentially pay more for toothpaste. Who would have thought? And the model does reproduce that as well. So that's cool. Also, the shape is really similar. And then the other big influence that is affecting these ratings are age. So age and income. The other ones don't really play much of a difference. They also don't in the other models. But here we're looking at how we can reproduce those age effects. So we see in the real surveys here, as you get older on the x-axis, there's this inverted U shape here. And that for me as well is like, okay, well, that's a pretty specific pattern where I'm not sure whether that should be in the model, right? But it does reproduce it. So these two effects, I think, are pretty nicely reproduced and really, I think, strengthen the story. There's other things like price sensitivity, different categories, right? And to sum up, the SSR method reproduces product rankings, survey distributions, and response behavior. So we get all three of them. And the text responses allow for qualitative analyses, right? This is what we've seen. And then there's even some benefits over the real surveys. I mean, obviously, it's a lot cheaper and faster, but also you don't have the positivity bias and you get more informative responses. Yeah, and like I said, you are not restricted to surveys. We're now launching a product that is for ads, basically. So you upload your ad and you get synthetic responses. But yeah, thank you for your attention.
Thank you so much, Thomas. I'm still as amazed as you are, to be honest. And the correlation with age is the cherry on top of everything for me. And correct me if I'm wrong. So that was purchase intent. Correct me if I'm wrong. You also saw, I don't know if you quantified this, but you saw the desire to try novel things correlate with age in the sense that teenagers, people in their 20s may be more prone to being interested in mango flavored toothpaste, for example, whereas as you get older, you're going to be less interested in trying something a bit more out there.
Yeah, that's right. So the fact that these effects are reproduced in this particular way definitely, I think, strengthens it.
Totally. And I'm interested in several things. Firstly, and forgive me if you mentioned this and I missed it, but there is no issue with, the first thing that comes to mind is their overfitting. And of course, you had a holdout set, which you made sure all of these synthetic surveys were performant on after the fact. And that's where your results come from.
That's right. Yeah. There is not that many hyperparameters. The main ones are the reference prompts. And there we did a little bit of iteration, but actually not that much. And also the texts themselves are pretty straightforward. It's obvious that no fine-tuning of the perfectly crafted responses has gone into it. Nonetheless, that is an area where overfitting can seep in, and then with holdout data that gets stabilized, but even the in-sample, I actually expect to not be that overfit.
Makes sense. And Inayat has an interesting question. How are you getting, and we're not asking any secret source here, but how are you getting the personas into the prompts? Are you merely specifying age, or Inayat asks, are you, for example, saying this is an old age pensioner or a single parent, wealthy couple, these types of things?
Yes, and I should have mentioned that early on, but the way we prompt the LLM is by giving it the demographic information. You are middle-aged housewife from the Midwest, blah, 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 income level. And then we show them an image of the product and the text next to it, and then just say, how likely are you to purchase this? So yeah, that's basically how it works.
Super cool. Jake has a couple of wonderful questions. Just for a bit more context, we had a workshop on iterating on prompts and prompt engineering, among other things, last week. And some people in the community and course iterate 10 to 20 times before getting something that's good for their production use cases. Some, and I don't know whether Nathan or Natalia are here. Natalia works in the healthcare space, and they'll iterate several thousand times, right? So I wish we had time to get a poll of people here, how many prompts they think Thomas and his team would have iterated on. But can you give us a sense of how many times you needed to iterate on the prompts?
Yeah, Ben told me it's like 8 or 10. So
yeah.
Low double digits.
Oh, Carol has a wonderful question. Carol's heard of synthetic data being generated for drug and virus responses, which of course is inherently a more high risk scenario than what we're talking about here. So do you have a sense of what the downsides of synthetic data generation are in higher risk domains?
Risk domains. Yeah, interesting. I hadn't thought about that, but I definitely would imagine that is pretty difficult to justify, right? You need definitely a lot more trust in the method that it does reproduce these effects. Yeah, it's hard for me to say, but certainly you can validate these methods, right? So if you took this and we have code on GitHub and you have some reference surveys or whatever you want to compare it to, then you could just like try.
Absolutely. And something I'm hearing in there, and something, we had a big workshop on evals earlier this week. I do think having a robust evaluation framework in order to develop trust with your system, and even down to like maybe you want to think about statistical significance and like at certain thresholds what your risk tolerance is as well. So I think evaluation and making sure that your synthetic data is representative and having test coverage around actual user input as well. We're gonna have to wrap up in a couple of minutes because we have a workshop starting in 3. We have so many more interesting questions in the chat. So I don't know. I can get to some. I don't know if Thomas, you want to jump in later. I appreciate how busy you are at the moment. So if you have time, that'd be great. But no worries. If not, Caleb has a great question around, do these Likert scale scores ever suffer from the kind of messy human noise in data from like extreme personalities? Did you ever see some people just always strongly disagreeing or strongly agreeing, for example? But
yeah, I mean, those things are definitely in the survey data, and we do filter some of that out if it's just like too outrageous. And I guess that's another benefit of the synthetic consumers. They also have less of those erratic behaviors.
absolutely. So we will wrap up now. I just do want to say Nicola has a wonderful comment around what expectations we can have around this approach to work on consumer populations outside the US. And I do know people who are thinking, I mean, Gael at INRIA and Scikit-learn is thinking a lot about European language models and what that would mean and whether they would be more representative. We have people in Australia as well, Nicola, thinking about what an Australian language model would look like. I wonder if you prompt ChatGPT to be like, just be Australian. I'm half joking there because it's no...
Actually, I think that probably will work. Yeah, I don't think there's a lot of reason to assume that it's going to be US only. I mean, there are definitely biases in the data set, but nonetheless, I mean, those models are trained on all the data.
Yeah, I just find when you prompt ChatGPT to be Australian, it just is nowhere near as funny as we are as a people. That's part of my bias. And Caleb, really thoughtful comment around wondering, and if there's a world that political messages get focus grouped by LLM panels, and this is part of a dystopian future. To Jake's point, these types of things will happen in our dystopian past, present, and future as well. I don't want to end on a note of dystopia, though. And something I actually want to thank you for, Thomas, with all the forces, AI forces and pop culture forces and media forces, I can get cynical about large language models every now and then. And you're one of the few restorative forces to help me remember what magic this is and how wonderful they can be. So thank you for that, and thank you for coming and giving such a wonderful talk to the group as well.
Thanks. That's such a great compliment. Yes, I'm very bullish on AI and see huge potential.
Yeah.
So yeah,
All
thanks for having me. Thanks for the
Always
questions,
a pleasure,
everyone.
Thomas, and chat soon. See you all in the workshop in 30 seconds, everyone. Ciao.
Bye.